All right, thanks everybody. Just checking that. Can everybody hear me in the room here? Yeah, that's okay. And hopefully the live stream is getting some audio too. And we'll get started. Okay, so also using Google Drive or Google Slides, which is always a bit of a risk. But anyway, so we're going to start off this morning with something super technical. So I hope you've had some coffee. You guys are feeling a little bit alert. Ready to learn something new, hopefully. But just to get a feel for where people are at right now, how many people have done any scripting, programming, coding of any kind? Okay, a good number of you. Okay, so maybe most of this will be kind of already familiar. How many people use Maya as a 3D application? Okay, so less of you. Okay, how many people have used Cinema 4D as a 3D application? Okay, good to know. Any other 3D application? How many people have used neither of those but a different 3D application? Okay, a couple of people. And how many people have never used a 3D application? Okay, so good. Okay, so that's good to know. All right, so why script? Well, there's a bunch of reasons, but if you haven't done any scripting before, I'll give you a few things. So maybe your software can only do X, Y, and Z, and you want it to do something else, but it can't do that out of the box. Well, you can make it do that. Basically, you're expanding to an unlimited set of tools available. Automating the boring stuff. How many of you have spent a whole bunch of time doing super tedious operation 54 times, and then you have to do it all again because something changed? Yeah, not that fun. You can script and automate the boring stuff. Don't be limited by the manual effort required to do something really cool. You know, sometimes you can use scripting to take advantage and create some more sophisticated effects and rigs and do some neat things. And finally, of course, you get some hacker cred, which is always fun. Okay, so scripting is about sending commands one by one to the software to execute. In this case, I'm showing you an interface Maya. It's pretty similar in any other kind of 3D application. So we've got a script editor here, and we've got this command here, polycube, and that's going to tell the software to make a cube. But the thing is, when you're doing something, pushing buttons and clicking on menu items in the 3D application, behind the scenes, the application is still sending those same commands to itself, kind of, and doing the same thing. So if we wanted to do that by skipping the buttons and menus, we could just write the command, skip that step, and do the same thing. Now, if you combine a few commands together, you've written a script. So for example, polycube, well, okay, that makes a cube. And then, okay, this is a long one, poly extrude, facet, stuff, keep faces, thickness. You might guess that, okay, so we're extruding stuff out, not too tricky. And then a poly smooth, divisions 3, you might be able to guess, okay, that's just gonna smooth that. So if you run those commands together, it's just gonna do all of those things in one step, and you've got yourself a little script. And each line is executed like you would read from the top, one by one, down to the bottom, starting at the top and stopping at the bottom. So you can create useful scripts without really any prior knowledge just by copying and pasting commands from the script editor in Maya or Cinema 4D's script log. Because what those little panels do is they echo the same commands that you're causing to be executed when you're clicking on buttons and menu items. So you just grab those, copy and paste them, maybe do a little lookup as to what they're actually doing, and then you've got yourself a little script. Okay, so I want to introduce you to Python. How many people have used Python before? Okay, good number, so that's great. Okay, so most of this will just be complete review for you, but maybe you haven't used Python in Maya, or maybe you have, or Okay, so Python is a programming language. Different applications can use different languages to send these commands. By default, Maya, the default language is Mel, and those commands you saw earlier are written in Mel, and that's Maya embedded language. So it just comes with Maya, it's embedded, and it's only used in Maya. But Python, on the other hand, can still be used in Maya, but it's a very powerful and very versatile language. If you know some Python, you can use it to control Maya, Cinema 4D, Houdini, Blender, Nuke, Fusion, your operating system, Google Sheets, databases, scientific data, the web. So you can use it for a tremendous amount of things more than just your 3D application. So you're not doubling up on your learning by learning a whole bunch of different languages. In my opinion, Python is a great one-stop shop for doing a whole bunch of really cool things. Okay. Oh yeah, and Adobe and Pixelogic should feel bad because they're not in the Python sphere yet. Okay, so let's compare Mel and Python. So we saw in Mel, polycube is going to make a cube. Okay, in Python, what do we need to type out? Oh, that looks a lot more complicated. What's going on here? Okay, well, it's not too bad. The first line here, import maya.cmds as cmds, is basically giving Python access to all of the Maya commands. Mel already knows them because it's Maya embedded. It's already embedded in there. Python doesn't know about Maya until we tell it about Maya. It's like, whoa, I know Maya now, right? It's just injecting all of that data into the consciousness of Python. And then, so this maya.cmds is all the Maya commands, and then we give it a little nickname, just a short form, cmds, so that we don't have to type out that whole thing every time. And then that forms the prefix for all the commands that we want to type. So cmds.polycube, it's the same thing. And in Cinema 4D, it looks very similar. Import Cinema 4D. I know Cinema 4D. And then Cinema 4D.baseObject, blah, 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 cube. I haven't done that much of Python in Cinema 4D, so my experience is less there. And there are some differences, but the stuff that I'm trying to give you today is hopefully applicable to a broad variety of applications. But most of it will be kind of Maya-centric. Okay, so far, script creation workflow. So we do something in the user interface, click a button, click a menu, see what command was echoed in the script editor, the command log or whatever. This is important. We can look it up in the Python documentation. So in Maya, the commands are echoed in Mel, but in the documentation, it'll tell you what the Python version is, what all the options do, give you some nice examples for how to use those. It's really great. And Cinema 4D also has good documentation for all the commands, and it's good to check those and see how to use them, because they often have really great examples. And then just add that to your script. So if you're automating something boring and tedious, you're clicking the same buttons in sequence on this object and then doing the same buttons on this object, doing the same buttons on this object. It's pretty easy to see that you can do all of this together in one step. Cool. So Python can talk to Maya and execute commands and make Maya do stuff. All right, let's dig a bit deeper into some fundamental scripting ideas. All right, variables. You've probably heard of variables. Pretty quickly, we run into an issue where we want to hold on to some information while the script is doing its thing. So let's look at an example here. So we want to look at the height of a sphere here. This is a silly example, but very simple. And then we want to create a cylinder that's as tall as that. So how would we do that? So if we think about it, we could say, okay, so if we create a cylinder that's just 1 unit tall, we could scale that up to like half the height of where the sphere is, and then move it up like half the height again. So half the height is moving it up, and half the height is scaling it up, and we should end up there. I tried it out. It works, trust me. But how would we do that? So how would we get that height of the sphere and tell Maya to use that piece of information somewhere else? Okay, so we need to use variables. Now variables, you can think of them as little boxes with a sticky note on it. So we can put all kinds of information into the variable, some kind of data, and we can tag that with a helpful name so we know what that piece of information is about. So for example, we might have a number, 6.5, that we want to store somewhere, and we can give that variable name ball height. So we know that ball height has a piece of data. What's that data? We can look at it and say, oh, it's 6.5. Or we can use, instead of numbers, we can use a different kind of variable. This is p^1, so it's the name of an object. So this is called a string variable because it's a word, it's a sequence of characters and digits and stuff like that. And we could give that the name myObject. Okay, so we have a method of storing pieces of information. What would that look like in our example? Okay, so this is the command in Maya, at least, that we use to get values from objects in our scene. So CMDS, again, we've got that Maya command prefix, so we know it's a Maya command. GetAttr is short for get attribute. And then you can kind of guess. So we're looking at the p-sphere 1, and we want to find the translate y value of that. So it's just going to return the value of how high that sphere is. OK, so Maya looks at the scene, returns the value 6.5, and then we can store it somewhere in our little variable called ball height. If it was at a different height, we'd use the same code, but it would return a different value 4. So that's why it's called a variable, because the value can vary and take on different values. It's not hard code, it's not set in stone. OK, so this format is one of the most fundamental ideas in scripting. This is kind of the basic how you store information. So on the left side, we've got a variable name. And then the equal sign means we're storing pieces of information that come from an expression or a command, something that returns a result, like that get attribute command that we did before. But it could also be something as simple as just 2 + 4, or a simple math expression or something like that. We're storing the result of that in a variable. In this case, we're calling it num_sum. OK. So remember, we wanted to get the height of the sphere and then store that in our ball height variable. So what does that actually look like with code? OK, so on the left side, we've got our variable name, ball height, equals. That means we're storing the value that's returned by that getAttr command. And behind the scenes, that's going to evaluate to, you wouldn't put this in your code, but this is going to evaluate to ball height equals 6.5. That 6.5 is going to get stored. And now we're going to use that piece of information in the next line. So we've got setAttr. This is like how you set attributes. You can set values. So in this case, we're going to set the scale y of the cylinder to be half the height of the ball. See, we're using that ball height variable there to some use. And that's going to evaluate to basically that, set attribute to 3.25. And then same thing, we're going to translate it y to the ball height divided by 2. And we get that result. So no matter how high that ball is in our scene, we're going to get a cylinder that exactly matches it. So that's making use of a variable to kind of do something useful. All right, so a couple more concepts before we can put together a little example. Lists and looping. These are really useful things. OK, so instead of a single piece of data that we store in a variable, we can put a series of data points together in a single variable. So for example, we could have a list of numbers. And the syntax for a list here is just square brackets surrounding it. That tells the system that it's a list. And then we've got comma-separated values, 12, 4, 7, 6, whatever. Could be any length. And then we're going to all store that in this list variable called data points. Or it could be words, could be names. White, blue, green, stored in a variable called colors. Or maybe a list of object names. You might see where this is going. And we can iterate over this list. What does that mean? OK, so for each item in the list, we can perform the same set of commands. So this is a very, very useful command. And there's probably an analog in any application that you'd want to do this for. In this case, yeah, we see that it's a Maya command. And the ls is short for list. So it's going to list something about your scene. And in this case, what we want to list is what we have selected. So if we've got a bunch of objects selected, it's going to return a list of object names. And we're going to store that in our variable that we've happened to call mySelection. OK, so in this case, we happen to have selected a cube, a sphere, and a torus. That's all going to get stored in this list. And that's going to go into mySelection. So regardless of what you have selected, you can get that information into your script. Why is that useful? Well, we introduced the for loop. Now, the for loop is a great way to do the same thing many, many times on different things. So this is the structure of it, and I'll kind of break it down. So there's 3 important points. So we've got for object in mySelection, colon, and then some stuff. So what does that mean? So mySelection was our list variable, right? That's storing all of the things that we had selected. And we also need just a temporary variable, you can call it whatever you like, that's going to hold each individual item in that list in turn. So first it's going to hold the first item in mySelection, and then it's going to go through this list. So These lines here, they're not actual code. They're just things that you might want to do. So create a material called the object name underscore material, and then assign that material to the object. That could be pretty handy. You can automatically create a whole bunch of objects, a whole bunch of materials, and assign one to each object. So in this case, the variable object would first have the value p cube 1, and then p sphere 1, and then p torus 1. And it's going to go through that 3 times because there were 3 things in our list. All right. We've looked at commands, variables, including lists and for loops, lots of stuff. Hopefully you're still with me, kind of. And let's put this all together with a couple quick and useful examples. So the frame converter. Let's say we've got a list of data that corresponds to keyframes in an animation that we have, and it's a 60 frames per second animation. But we want to know, okay, so where would those frames be if this animation was at 24 frames per second? Okay, so we just need to do a little bit of math, right? So we have a frame that's 120 at 60 frames per second. That would be 2 seconds. So at 24 frames per second, that would be 48 frames. Okay, so how can we do this automatically? Well, we can use a for loop. Okay, so we've got our list data, and then we're going to loop on each of those values. So we're going to do some math. Okay, so here we've got on the right side, we're evaluating an expression. F, remember that was our temporary variable to store 0 to start off with, and then 50, and then 120, and then 130. So we're going to do, let's take 120, F divided by 60, 2 times 24 is 48. And then we're going to store that result in the variable called new F, new frame number. It could be called whatever you want. And then we just print that out because we want to see that in our script editor or wherever we're getting our output of the script. So we're going to print the converted number. So this is going to take whatever input you want, a list, and then it's going to give you the correct values without having to pull out the calculator or doing other tricky stuff. Okay, the object randomizer. Okay, you've got a bunch of objects in your 3D scene, and you want to just give them random rotations so things look a little jumbled up. Now, yes, there are other ways to do this, but let's say we're using a script here. Okay, looks maybe a little complicated, but let's break it down. Remember, whoa, we're bringing in all the Maya commands. We have to do that at the beginning of our script so that Maya knows how to deal with Maya, or so that Python knows what to do with Maya commands. We're going to bring in something else, import random. So that's going to bring in some tools that we can use for random number generation. That can be pretty handy. Now, we've already seen this before, but this is a little bit abbreviated. So we're just saying our selection, SEL variable, we're going to store the current selection. So the SL is short for selection. So command, list, selection, yes, okay. And then iterate. We've done this before. So for every single object in our list of selected objects, we're going to set some random rotations. So you can see here, we've got a set adder. It's a Maya command. On the rotate X of our object, we're going to get a random value between minus 180 and 180. And then do the same thing for rotate Y and do the same thing for rotate Z. All right, so now we've actually created something useful. This level of complexity of script can be really handy in a lot of situations. Maybe not exactly this, something similar. And it just takes a few minutes to write, and it can save you minutes of effort. Okay, so before I run out of time, I wanted to give you, if this piqued your curiosity, you think you might like to dig a little deeper into Python. Wasn't hoping to like teach you Python or teach you exactly how to script. I want to just give you a little peek inside what it means, what it looks like, why it's useful, that sort of thing. So hopefully I've done that. There's an app you can get on your phone. It's free, Solo Learn. You can do some little Python, little training bits. You can do that on the go, on the train, on the toilet, whatever. It's fun. It's interesting. Lynda.com, if you've got a Toronto Library card or similar, you can have free access to lynda.com. Or if you're in school, obviously, you can get that. Tons of Python courses. There's like Learning Python, Python Essential Training, the basics, all that sort of stuff. And these are not specific to 3D applications. These are general Python understanding, which is still very, very useful. There's a couple of free books, Automate the Boring Stuff, Invent with Python. They're kind of fun little Python things. Code Wars is a cool website where you can kind of do like daily puzzles or weekly puzzles to kind of improve your skills and learn new things. And sorry if this is a little hard to read in the font color, but PactPub is a publisher that makes ebooks, and they've got a lot of the Python ones for free. So most of these training tools will use Python version 3, which is a little bit different than Python version 2, and unfortunately Maya, and I'm pretty sure Cinema 4D still use Python 2.7 or something like that. So there will be a little differences, so there's something to be aware of going in. Free Maya Python resources. Chad Vernon has a great little PDF document, Introduction to Python Scripting for Maya Artists. I'd recommend that if you're interested in doing this. It's not too difficult. It breaks it down really nicely. And then Autodesk has a little series of YouTube, I think there's 5 videos, Introduction to Python Scripting in Maya. Gives you kind of a crash course boot camp in doing that. If you want to dig in a lot deeper, an advanced book, Practical Maya Programming with Python by Rob Galanakis. If you go onto the Tech Artists website and go onto their Slack, I think there's a way to get it for free because the author is part of that community. Anyways, Cinema 4D Python resources. Thanks, Nick, for some recommendations here. Cineversity, the documentation, obviously. There's if you look at Python scripting for artists, there's a Vimeo video that somebody's created some little helper things to help you get started with that, which is a kind of nice little intro to that as well. And there's a couple other resources there. I'm assuming this will be recorded, or you can take a picture or whatever and look at this after. Okay, so I think I've got a couple minutes for questions. Happy to take any. Thanks for listening and your attention. Sorry to get you something so intense right off the first thing, but kicking it off. Any questions? You're all experts now. Yes. Okay.
Great. All right. So I'll be giving quite a technical talk, and you should believe everything I say, because I know how to do things like press buttons and work microphones. So today I'll be talking about taking control of your visuals in Unity and other unpopular opinions. Unity is kind of thought as a development environment. It's thought for a space for programmers to work in. It's not really thought of as a place where you can be an artist and really take control of your visuals and develop a look. That's something we actually have to do every day. So what's nice is that relatively recently, Unity has released a whole suite of tools intended for artists, not for programmers to use. And I'm just going to be giving a really brief look at those tools today. There's really not enough time to kind of dive deep into them and give it a tutorial about how to set these up and really use them. So And these are just a few things. So I'm going to be talking about the HDRP, the high definition render pipeline, the new post-processing stack, and the thing I'm most excited about is Shader Graph, a built-in shader editing tool. Now, just a word of caution before we start. All these tools are technically in preview, so they are available. You can download them in the latest version of Unity right now, which is 2018.2, but they are in preview, which means they are stable, they work, but they are subject to change. So when they're fully released, some of the things that you've built now may not work in the future. So just a word of caution. It's a great time to learn these new things and play around with them, but they are not production ready. They're not MRP ready, just to let you know. So just a little history of graphics in Unity. Unity actually came out in 2005, and it was a game engine that was developed really to make this game called Goo Ball. And it was for the Mac, and it was kind of like Super Monkey Ball, where you kind of had to tilt the ground around and roll this ball around. But you can see the graphics are kind of typical of what we associate with video games. They're not great. They're not meant to wow anyone, but they're kind of fun. And for a long time, looked just like this up into doing, when I was in BMC doing my own MRP in 2014, graphics really hadn't changed that much. There were a few options, but really the way things were rendered stayed the same. In 2015, things changed a bit. So in Unity 5, they released physically based rendering in Unity for the first time. This was a demo they made called the Blacksmith, which is really very dark on this screen, showcasing some of the new rendering capabilities, showcasing the new standard shader that they created and the physically based materials that it could support. I'll wait till he creeps out into the sunlight so we get a better view. But needless to say, this was an exciting time. Things changed very, very quickly. And suddenly what we thought of as kind of graphics and rendering in video games was quite different. So that's great. So where does that lead us to today? So I'll talk a little bit about what we could call the Unity render pipeline. So up until now, Unity has had what's called the built-in render pipeline. So this was kind of a black box in the program. You really had no control over how Unity would process your graphics, how Unity would handle your lighting, really at a low level. And this was done intentionally because really the purpose of Unity is to democratize game development, it's to create an author environment where you can kind of design and develop in one place, but target multiple platforms. You could target game consoles, high-end PCs, but also mobile devices and websites. And they had to build essentially a rendering pipeline that would support all these different platforms. That may sound great, but what you kind of end up getting is the worst of all those worlds, not necessarily the best. So if you're developing a mobile game, you've got a lot of extra overhead and kind of performance-hungry features that you're never going to use just because that rendering pipeline is also suited for PCs and consoles. And if you're developing for PCs and consoles, well, you can never really push your graphics to be really as kind of high quality as something like Unreal Engine or Crytek that just target those platforms. Just this year, Unity has released what's called the scriptable render pipeline. So you can actually create your own render pipeline from scratch. You can write it. It's incredibly hard. I don't recommend it. So what they've actually done is release 2 example render pipelines. One is the lightweight render pipeline, which prioritizes performance. This is great for mobile game development, for VR. And what I'm going to talk about today is the high definition render pipeline, which prioritizes visual fidelity and high quality. So this is great. There is one big downside to this, is that you have to sacrifice some of the cross-platform functionality of Unity. So when you start a project, you to either a lightweight render pipeline, the built-in pipeline, or the high definition render pipeline. You can't change midway through your project without seriously breaking things or having to go back and rework a lot of things. So as an example of this high definition render pipeline, Unity just this year released this demo. So this is real time. It's called the Book of the Dead. This was all built within Unity. There's no post-processing or, After Effects playing a role here. What you're seeing is actually in engine, in real time, playing back. Yeah, a really creepy guy here. And he'll run off here. Which is fantastic. It's great to see this stuff happening in Unity. What this has done is not only open the door for what we can do in games, it's opened the door for what we can use Unity for in general. So it's normally been called a game engine. They're sort of rebranding and now calling it a creation engine. Because what we're seeing now is Unity being used for things like film. This is my daughter's hero, Baymax, from Big Hero 6. So Disney recently used the high definition render pipeline in Unity to release a series of shorts called Baymax Dreams. These are all on YouTube for free if you want to check them out. So again, this is all just done in Unity. This isn't a game. This is just a video that's been produced within Unity. Assets are still made in Maya, animations are still done in Maya, but all the rendering and output is done right in Unity. This is a film that was released this year at SIGGRAPH called Sonder. Really dark. They need to make some nicer demos with some lights. But yeah, we're perhaps going to see this more and more. Unity used not just for interactive applications and games, but for actually films, potentially MRPs and medical visualizations. So let's get into it. So I'm going to be talking about the high definition render pipeline first. I'll be doing a really quick fly through of how to set it up and what the output looks like. So just by show of hands, does anyone here who uses Unity? Has used Unity? Is thinking about using Unity? A few people. Okay. So a lot of this may be familiar to some of you, some of you may not. But essentially, if you go into Unity, things kind of look like this. Everything just has a kind of Lambert shader on it. It doesn't look especially great. So I've created a new project here, and I've now defined that I'm going to make this project in a high definition render pipeline. And at first glance, it doesn't look like much. This is the scene view here. So this is just a model. This is a little snippet of DNA we created for a game at Axis called Guardians of the Genome. Stuart actually modeled the nucleotides here, and our devs created a script to kind of procedurally generate these strands. If I go into my game view, this is kind of how it's lit, and this is kind of what we typically see in a lot of games. Really dark, hard shadows. Still kind of a Lambert shader. If you poke around in the interface, the first thing you'll notice is that the lighting system is a bit different. So you can place lights in your scene, but everything is now physically based. Everything is meant to behave as a light would in reality. So you may notice if you're controlling the intensity of lights, you're now using units in lux and lumens. You can control temperature as well. And all this is to kind of reflect real world lighting. So right now it doesn't look like much. What you really need to define in the high definition render pipeline is something called a volume. And that's going to make no sense. But here I've created a volume component, and it will create essentially the visual environment. So in real life, if we're in this room, we don't have like one directional light providing all our lighting, creating these dark shadows. We've got light bouncing off the walls. We've got multiple light sources here. If we're outside, the sky lights our environments in very different ways. So the volume will take care of that. So in a volume, I've defined a procedural sky and exponential fog. And you can see that the lighting is a little more, it's softer now. We're not getting those dark, hard shadows anymore. We're getting kind of some nice speculars instead. And let's look at the model itself. So another big difference in the high definition render pipeline are the materials you're going to deal with. So if you've used Unity in the past, physically based rendering was handled by the standard shader. That won't work anymore in the high definition render pipeline. That's been replaced with the lit shader. Functionally, it works very similarly. So you can add things like your texture maps, your normal maps. You can control emission, define the metallic and specular properties of the material. If we zoom in here, though, the thing I'm most excited about is they have a bunch of material type presets. So you can now use this pipeline to render things like anisotropy, iridescence, specular color, translucence, and way up at the top there, they even bumped it. They didn't decide to even put it below standard shader. We've got real-time subsurface scattering is now possible in Unity, which when I first heard this, I couldn't believe. So this is very different than these types of materials you'll use in Maya or Cinema 4D. This isn't, they're not ray tracing solutions, but they are pretty amazing. So let's go ahead right away and turn that on. So let's put on that nice subsurface scattering on our material here. And already you see the visual fidelity is starting to improve. It looks a lot different from that Lambert we started with. So switching over here, let's talk about the post-processing stack. This is where you can really start to feel like an artist and start kind of tweaking the visuals and kind of developing a signature look, a mood to your work. So the post-processing stack replaces the image effects from earlier versions of Unity. So essentially, the previous image effects were kind of like scripts, components you'd add onto your camera, and you kind of just layer these effects one on top of the other. And they were okay. You can make things kind of bloom, and you could add depth of field. But they were very, very expensive, very, very power hungry. The big advantage of the stack is that it kind of takes all these things like color grading, bloom, vignetting, ambient occlusion, motion blur, depth of field, auto exposure, chromatic aberration, and renders them all in a single pass. So it kind of makes all those calculations and just does it at once. So you can get a lot more out of your hardware, a lot more out of your computing, essentially. And these have really been expanded on. So I love this is just the color grading tab expanded in itself. And that's fantastic to work with and play around with. And there's tons of options in here to work with. So let's fast forward here. So here's where we started with. I just kind of messed with my materials. Now let's turn on the post-processing stack. And this is what I'm getting now with a bunch of effects in. And this is still really running really, really well. We're well at over 100 frames per second as if I'm playing this just on a PC with a 1070 graphics card. So it looks really, really neat. But I think the big advantage of doing this in Unity is that you're using a real-time game engine. So if you want to kind of alter your materials, alter these effects, or even just explore, you can do that all in real time. So here I've just got a camera script. I'm running the application. And let's go around this DNA and take a look at it. And I'll say it looks okay, but maybe I got too overzealous with that subsurface scattering, so maybe I want to turn that down a bit. My bases kind of look like Christmas lights, so let's tone down that emission. And let's keep exploring. So we can do all this in real time, and I think that's why we're starting to see this pipeline used in film a lot more, is that now we don't have to worry about kind of bottlenecks from rendering out shots. We can just prototype and refine our look in real time. Okay. So that's great, but don't stop here. So don't go out and just do that. That was a great demo. The title of this talk is Taking Control of Your Visuals in Unity. It's not letting Unity take control of your visuals, which is a danger. We could run into this sort of situation. So here's my next unpopular opinion. You may notice this, but as kind of technology gets better, in our own field, we may see kind of the drive to make things more and more photorealistic, just because it's possible. Personally, I don't think that necessarily means it makes better communication tools. I don't think that makes better scientific visualizations. And so when you use this tool, I'd say use it, you need to think more critically about it. I think when we make things look really real, we imply something about the accuracy or how confident we are in how those things look. I had this great HoloLens experience where I saw atoms kind of come up in front of you, but they used the kind of Bohr-Rutherford model of it. So you saw like, a nucleus with electrons flying around it. And my first thought was, wow, this is amazing. It looks so real. My second thought is, as a former science teacher, I would never use this because the Bohr-Rutherford model is really just that. It's a model. It's a way to think of, explain certain parts of how atoms behave. But say when I get to grade 11 chemistry and I'm teaching kind of VSEPR theory, they have to unlearn all that. But by making something look real and implying certain confidence about that, I think that makes it harder to learn those things. And yeah, so how do we address that in our visuals here? I'm gonna just push through this really, really quickly here. Am I okay on time? Did I start a bit late? Oh, I'm gonna go slow then. Really when I get into Unity and start working here, start thinking about taking control of my visuals, I don't want to just go in and tweak a bunch of dials. I don't want to just kind of rely on what someone else built. I want to build something myself. And I think we see a lot of this in the game industry in itself. You've got kind of AAA games like Call of Duty and that really emphasize photorealism to kind of sell their games. Everything just has to look more and more and more and more real. Red Dead Redemption 2 came out and everyone's like, oh my gosh, look how real the dogs look, and the horse will kick you if you touch it in a certain way. But yeah, realism is great, but does it really tell your story any better? And what I like seeing kind of the game industry is that we're almost seeing a bit of an impressionist movement where people are kind of abandoning photorealism for really kind of undefined contours and forms, but still really beautiful, realistic lighting. So when Unity 5 came out and we had physically based rendering for this time, we didn't see a whole bunch of photorealistic games come out of industry. We started seeing things like this. So this is Ori and the Blind Forest, built in 2015 in Unity. Firewatch won a ton of awards. Again, really kind of simple, cartoony kind of style, but beautiful, well-lit environments, really nice interplay of light. If you played Monument Valley as well, again, these aren't photorealistic, but they're stunning and they're beautiful. And all these were built in Unity. This was not built in Unity. This is Legend of Zelda Breath of the Wild. I'm addicted to this game right now, and it's huge, it's open world, so many details. Such a well-defined, polished game. This is by Nintendo, like a big studio, but again, a really kind of soft, not really photorealistic, almost a cell-shaded style that they've decided to go with. Which brings me to shader graph. So if you really want to start doing things like this, taking the rules that the HDR pipeline kind of sets up, or even the lightweight render pipeline, you have to take those rules and then you have to kind of break them. And that's where shader graph kind of comes in handy. So really all this rendering that we're seeing is controlled by shaders. You've probably heard that term before, but shaders are really just programs that render pixels, right? Take kind of 3D data and decide how those should translate into pixels on a screen. And that's a very high level description of it. And up until now, that's normally been done just by writing any other program just through code. And the typical language in Unity and lots of these game development engines is high-level shader language, or HLSL, which is super complicated. I've worked in it a little bit. It's hard. It's hard. So if you're working like in Python and C#, in Unity, that's great. Shader development is like a whole other level. Like I meet someone who really knows how to write shaders from scratch, and they're like, I don't know how they exist. I don't know how they've learned these skills. So it's been hard, and not a lot of Unity developers actually have that skill set. It's normally handled by a technical artist, someone just dedicated to that. But what Unity's now released is something called Shader Graph, which is a node-based editor for creating shaders instead of writing them from scratch. And there's been other third-party solutions like Shader Forge and Amplify Shader Editor you may have heard of, but this is now built into Unity. So I'm always hesitant to kind of suggest a third-party plugin because support may drop for it, you never know, but this is now built in. So I'll show you just a quick example of how to use Shader Graph. I'm actually going to go into the lightweight render pipeline. So this is how things kind of look. Not bad, not as good as before. If you open up Shader Graph though, this is kind of what it looks like. And it's really just about, this will take some practice, but it's really coloring, it's painting by numbers, but those numbers is vector math essentially. Let me see. Susan, am I good on time? Yeah, it's good time. All right. So really, it sounds really complicated, but all shaders really do are render triangles. So I've got like triangles in 3D space. So I've got a triangle here. I've got a bigger triangle here, so everyone can see. So if you were just sitting at your desk there and sketching it, if you wanted to draw this triangle on your flat piece of paper and shade it in, what are some things you'd need to know? What are some things you'd pay attention to? You gotta be louder. I know we're all like we're introverted visual communicators, but just shout it out. Light source, yeah. So we need to know what our light source is, where it is.
Surface properties?
Surface properties, yeah. So what it is, what direction it's pointing in, right? So if I just showed you this and I hit it and I asked you to sketch in your book, just knowing where the light source is, knowing this is made of paper, and knowing kind of what direction it's facing in, you could probably, crosshatch that, shade that in a little bit. And shaders work the exact same way. So here I'm going to try to develop like a really simple toon shader look, and all I really need is one, surface properties, or the direction it's pointing in, which is our normal, and I need our light direction. And I do some fancy dot product math, and that's what actually gives us our shadow and our highlights. I'm going to use this smooth step function now just to kind of make like a hard shadow and a hard highlight, and apply that to my DNA little buddy here, and that's what I get. So now I'm now taking control of how these things look like. And if you played Breath of the Wild, they've got kind of a similar toon shaded look here. They've got really nice kind of sketchy speculars. They look like they're hand painted in. And I think this is great because it doesn't detract from the story. If anything, it adds to the fact that this is kind of a fantasy story. You need to suspend your disbelief in a lot of cases. And someone on the Unity Connect forums actually decided to try to recreate this shader. This is still kind of using that basic setup I had, where just a dot product between the normal and your light direction. But then you add in things like your color and your specular and emissive values, and you get something that looks super complicated like this. But your product in the end will look a little like this. And of course, you can still use your post-processing effects. So that stack still works in the lightweight render pipeline. So let's add a bit of bloom for the heck of it, do some color grading, because that's always good. And of course, everything works in real time. So looking at this, yeah, maybe it doesn't look as expensive and flashy as the HDRP pipeline, but I made it myself. And if this, and depending on my communication goals, maybe I just want people to kind of focus on the structure of this molecule, just be able to tell one base from the other, or see how they pair up with one another. This might be arguably a better way to present it than with all the kind of flair of the HD pipeline. But of course, that's a very unpopular opinion. That's it for me. Are you okay? All right, I'm done. Thank you very much. Is there time for questions, or? No, okay. I'll be around. If anyone has any questions, come talk to me. I don't know everything about this. This is all very new. They had Unite LA last week, and they announced the visual effects graph. I haven't even started looking at that. There's so much new stuff in Unity. If you're thinking about getting into Unity or you're already using it, this is a great time to get into it or revisit it, because everything is different and everything is really exciting. All right. Sorry. Sorry I kept bugging you.